Hello students, this video lecture is prepared for the particulate technology subject, and I will discuss the unit number 3, that is separation of solids based on specific properties. So some part of this topic we have already discussed, that is classification, terminal velocity, gravity settling tank and cone classifier. Now we will discuss the remaining equipments like double cone classifier, rake classifier, spiral classifier and the cyclones. So here there is another equipment which is used for the classification of the solid material is called a double cone classifier. So this is actually the figure of the double cone classifier. So double cone means it is having double cone, that means this is first cone and there is another cone. So for that purpose it is called a double cone classifier. And in this double cone classifier, the lower part of inner cone is slightly cut and the outer cone is fixed cone and the inner cone is movable or adjustable cone. And at the bottom of these cones there is inlet is provided for the water and collection box is provided for coarse material separation. And at the top of this double cone the overflow is provided. So this overflow is separated fine solid particles. So this is the this is the construction of the double pipe cone classifier. So you have to just add the feed. Add the feed that is in the form of suspension, that means in the form of slurry, means solid plus liquid, to the center of the inner cone. So this is the inner cone. It flows downward through the inner cone and out at a baffles at the bottom of the inner cone. So here this feed is come out and the water is fed near the outlet. So water is fed from here, the solid from the inner cone and the rising stream. So rising stream means this is the rising stream of water are mixed below the inner cone. So in this area the feed from here and water is mixed and they flow through the annular space between the two cones. So this is called a annular space and the classification occurs in the annular space. So the classification is occur in this space. The small particles or fine particles are carried away in the overflow. So the small particles are going in this direction and the large particle or coarse particles settle at the bottom and it can be removed from this collecting box. So in this way we can separate the solid material with different size. So this is the construction and working of the double cone classifier. Then we will move to the another classifier. So these are the mechanical classifier. So first classifier is called a rake classifier, or it is also known as the sometimes door classifier. So it consists of a rectangular tank. So this is the rectangular tank with a sloping incline. So this is the sloping incline. The tank is provided with movable rakes. So this is called a rake. This part is called rake. The feed, that is slurry, is fed from this point, that means at the middle of the tank, and the lower end has a wear overflow. That means there is some provision is provided for removing the fine material. That means very small material which is not settled in this tank. Then the heavy material that means coarse material, is settle or sink at the bottom. So here that coarse material or larger size material is settled at the bottom of the tank, and this rake, so this is called a rake. So this rake move upward direction from this tank, and this coarse material is moving with this rake and discharge at this top of that rake classifier. And the fine material, that means very small material which do not settle here, they will remain near the slurry, surface of the slurry, that means here they are remaining here, while the heavy material or heavy particles are settled. So in this way we can separate the heavy material and coarse material by using rake classifier. Then there is another classifier known as the spiral classifier. Okay, so the working of the spiral classifier is the same, but here there is instead of rake, the spirals are used, and this tank is having a semi-cylindrical trough. So trough is nothing but it is just having a semi-circular cross-sectional area. So this is a semi-circular cross-sectional area, and this area is also inclined to the horizontal. So there is some angle is made to the horizontal, and this trough is provided the slow rotating spiral conveyor. So this is called a spiral conveyor, and the liquid overflow at the lower end. So this is lower end. So there is outlet is provided for the liquid overflow. The spiral conveyor, that means this conveyor move the solid material which settle at the bottom from the top of the trough. So the coarse material is settled here, and this material is moved by the spiral conveyor. So this spiral conveyor is rotated. So by means of this coarse material is moving in this direction. Then the slurry you have to feed. So this is the construction. The slurry is fed continuously near the middle of the tank or trough. The slurry feed rate is so adjusted, that means this rate is so adjusted that the fine material do not have time to settle. Okay. Then these fine material are carried out with the overflow, and the heavy particles are having time or provided time to settle. So these heavy particles are settled here, and the spiral conveyor, this spiral conveyor move the settled particles or solid material in the upward direction, and from this top of the conveyor that coarse material is discharged. So this is called a spiral classifier. Then we will move to the next equipment, that is called a cyclone or cyclone separator. So cyclone separator is generally used for removing the solid material from the fluid. So fluid is nothing but, I already told you, solid fluid is nothing but it is a gas or liquid. And what is the difference between the previous equipments and these? Here instead of gravitational force, we are using the centrifugal force to separate the solid material. So centrifugal force is used in the case of the cyclone separators. So there are generally two types of cyclone separators are used. So first is this cyclone separator. So this cyclone separator is used for the separation of gas and dust particle, that means solid particles, and this cyclone separator is used for liquid. This is called a liquid cyclone, and it is used for separation of solid and water or any other fluid. Okay. So first we will discuss the cyclone separator, which is used for the separation of gas and solid material or dust material. So the dust containing gas is introduced tangentially into this cylindrical vessel at high velocity. So this is the cylindrical vessel. So the gas containing dust, so it is known as the ladon. Ladon means it containing dust containing gas. So dust is having, that means solid particles. So these are introduced tangentially in this cyclone separator, and from this cyclone separator, the bottom part of the this cyclone separator is having a conical section, and the upper part is having a cylindrical section, and the outlet is provided at the middle of this section. So we have to just introduce the dust with solid particles from here tangentially. So by doing this, the centrifugal force is created here, and this centrifugal force throw the solid particles out against the wall. So solid particles are throwing by means of a centrifugal force at the wall of this vessel. So this is the vessel or cylindrical section, and these solid particles are dropped into the conical section and they are removed from this bottom, and the gas, clean gas, is taken out through the central outlet provided at the top. So the clean gas is taken out from the top outlet provided from the top. So in this way, the cyclone separator are working. So this is the working of the cyclone separator. And then in case of a liquid cyclone, you just have to add the solid plus water. Then the centrifugal force is created here. This centrifugal force again throw that solid particles along this wall, and these solid particles are collected with water, and some part of that water is also collected from this pipe, that is known as the overflow product. So fine material plus water is collected from here, and the coarse material plus water is collected from the here. So this is called a liquid cyclone, or this is called a cyclone, or we can say the gas cyclone also. So what is the difference between these two? The diameter of this cyclone separator, liquid cyclone separator, is slightly smaller because we have to create the centrifugal force and we are using water as a fluid here. Okay, so in this way we can separate the solid material from the gas also and from the water also. So this is the working of the liquid cyclone separator. Then we will discuss the remaining part in next lecture. So today's lecture we have already discussed about the double cone classifier, what is the working of the double cone classifier, then rake classifier, which is called also mechanical classifier, then spiral classifier, and then at the last part we have already discussed cyclone separators. There are two types of cyclone separators. One is called one is used for the gas plus solid particles are separated, and in this solid plus liquid particles or liquid material is separated. So it is called liquid cyclone, and this is called only the cyclone. So the remaining part of this unit we will discuss in next lecture.